My name is Solomon Kristen, and this is my report on the history and ecology of Kamiak Butte Historical County Park. This report will cover the ranging topics surrounding Kamiak Butte. These topics include the geological foundation of the butte, as well as its climate, woodland type, and other wildlife interactions between species within the ecosystem. Before the continent-based world that we see today, the Earth was believed to originally been on a supercontinent known as Pangaea. When the continent Pangaea split due to tectonics, the continents were formed. For example, North America was created by seafloor spreading and the creation of the Pacific Ocean by the hand of divergent boundaries converging against each other. This process is also known as subduction. Millions of years ago, the Pacific Northwest was completely underwater. In fact, from the coast of Washington State all the way up to the Palouse and Pullman where we are today was completely underwater with no land. Then, similarly to when Pangaea split, the subduction of the North American continental plate and the Juan de Fuca oceanic plate forced the Pacific Northwest, including what is now Washington State, above water. Flood basalts are, as the name suggests, floods of massive amounts of basalt that covered the land due to the eruption of fissures underground. Around 17 million years ago, a flood basalt covered the Pacific Northwest, resulting in 63,200 square miles of the area being buried by basalt, as seen in the slide. This aspect of the landscape is key when understanding the geological foundation of the surrounding areas of Kamiak Butte, as seen today. The reason that glaciers are so relevant to learning the history of this area is because they had a direct effect on the landscape of the Pacific Northwest as we see it today. Around 20,000 years ago, the landscape we see today in North America was nearly completely covered in glacial sheet. When the glaciers specifically that had clogged up Lake Missoula started to melt, they burst free and created a flood that covered the region of eastern Washington, as well as Idaho and Oregon. Similarly to how the basalt floods covered the land so many years prior, these glacial floods overpowered the land and created over 2,000 square miles of scablands that we see across Washington today. One of the most valuable aspects of the Palouse area, including Kamiak Butte, is the incredibly farmable soil that covers the land. The loess soil in the Palouse area were formed by strong winds that carried and dispersed large amounts of mineral-rich ground silt from glaciers that mixed with topsoil in the Washington and Oregon area to create a very fertile soil. Not only is the wind-blown silt responsible for the fertile soil, but also for the rolling hill structure of the Palouse that is seen today. Looking at the climate at Kamiak Butte, it has a huge role in the way that species live and how vegetation grows, as well as many other things. When looking at the topography and weather habits on each aspect of Kamiak Butte, we can begin to understand why the landscape and species interaction is the way that it is. Topography is the study of the land and different features of the land. Specifically, it studies the heights and depths of features on land. The landscape feature type of the Kamiak Butte is a summit that peaks around 3,586 miles above sea level. When looking at the north and south aspects of Kamiak Butte and its topography, we find that the north aspect sits at 46 degrees north and 117 degrees west, with a slope of 15 degrees and at 2,929 feet above sea level. The south side, in comparison, sits at the same slope of 15 degrees and it lies at 46 degrees north and 117 degrees west, just like the north aspect. However, the south aspect sits at a slightly higher elevation at 3,206 feet above sea level. Air masses can be defined as large bodies of air that travel through the air, and if one stays over a specific area for a long time, it will control the weather in that region. When looking at the air masses that we see in Kamiak Butte, there are a couple different air masses that this region experiences. In the summers, for example, we get hot and dry tropical air masses from the south, which quickly dries out the area and landscape. In contrast, we also recognize the cold polar air masses that come in from Canada during the winter months. When it comes to the temperature and precipitation at Kamiak Butte, the year-round average shows a fairly consistent pattern of hot and dry summers and cold, wet winters. This can be attributed to the diverse air masses throughout the year seen at Kamiak Butte. Kamiak Butte is split into two very diverse and much different north and south facing aspects. The north aspect is much denser with vegetation and canopy coverage, which contributes to a slower winter melt-off. This is much different than the south aspect, which has significantly less vegetation, more solar radiation, and a drier overall climate. The north aspect has around 130 trees per acre, whereas the south aspect has a much lower 35 trees per acre. This contributes to the significant difference in canopy coverage from the north aspect to the south aspect. The dominant tree type on the south aspect is ponderosa pine, while the primary species seen on the north side is Douglas fir. Tree size is another factor that is much different on each aspect, while the tree size is much larger on the north aspect, with the tallest tree in a given area being 112 feet. The largest tree or tallest tree on the south side in a given area was only 71 feet. Kamiak Butte has many stabilizing and disturbing factors. When it comes to the stabilizing factors of a given area, it always starts with the foundation. In the case of Kamiak Butte, the foundation is that of quartzite rock. The key thing that the quartzite foundation allows is extensive water flow. This water flow allows plants that have their roots deep within the soil to receive the water and nutrients that they need. One of the biggest disturbances factors of the butte, as well as all woodland type biomes, is wildfire. The latest fire was in 2016. The Palouse Fire Department claimed that they believed the fire was started from an illegal campfire by campers on the south side of the butte. Another disturbance factor, as seen in the photo, can come from species interactions. This photo shows a pine tree with bark loss due to woodpeckers scavenging for pine beetle larvae. The pine beetle kills pine trees by laying their larvae under the bark, which then take away the tree's nutrients and ability to survive. The tree will die within a year. I want to take this last second of my time to say thank you for watching, and I hope that you learned something about the Kamiak Butte.